And any questions on this? Yes, no? Huh? We okay? Okay.
I know the your PowerPoint is a little more in depth.
On Blackboard? They might be. They don't get up on Blackboard automatically, and sometimes and I make corrections to my PowerPoint all the time, and then of course I forget to upload them, so it wouldn't surprise me. But they pretty much will follow this right, except for probably this last section is not on here. Like this is probably not on there. That's been added lately. I think that's a neat slide though, because it's animated. And this is where we left off at, right here. What they've done is, or what the 70E standard done is it's brought out a lot of changes on what we do things. One of the things that it's brought about, which is really, really good, is what they've done is they've set up meter categories depending on what type of energy spikes these meters can handle. So we get transit spikes, transit voltages inside, especially power grid, all the time. And so what they've done is they've set up these category meters depending on what type of job or where you work at. Depends on where this meter would just about be guaranteed not to blow up on. So these are the category meters. We have Cat 1 meters. Now the further you get away from the voltage source, the actual source, the more you have to go through, these spikes have to go through to get to you, right? You understand? So like most electronic equipment is, anytime it goes to a transformer, anything like that, transformers have a tendency to block voltage spikes or block spikes. So we got a transformer on the pole, and then every electronic device has a transformer in it somewhere, right? You understand? So it says if I've got a Cat 1 meter, category 1, most people just call it a Cat 1, we can use this inside electronic equipment. So if I troubleshoot electronic equipment, then a Cat. Now, the category meter does not specify the maximum voltage your meter will measure. Usually the maximum voltage your meter will measure is written on the meter somewhere. So it would usually be the highest range that's available. I brought my camera out here, but I forgot to bring up the software. And it's usually written on the front. And then what they've done, and we'll look and see why in a second if the thing loads up. I guess I started it. Yeah, there we go. It says it's already running. It says there's a new version. I'm not going to worry about that right now. It always helps. So this is one of our meters. This is the one we use for meter certification. So right here, this is the category this meter is rated at. So it's a Cat 2 or Cat 3. It's a Cat 2 or Cat 3 meter, depending on where you're looking at it. So Cat 2 up to 750 volts, and then Cat 3 up to 600 volts. Does that make sense? Probably not. Well, that means this guy here probably can measure over 600 volts. But what they're saying is that we're protected up to 600 volts. And we'll see. We'll go up in with a minute. Yeah, AC and DC. So AC up to 750, and then then DC up to 1,000. And why is that? Well, a lot of people don't understand this is a surge, or this is a spike. AC, what we read on our meter on AC is not actually what's there. Y'all understand why? Because if I'm measuring 120 volts DC, if I'm measuring 124 volts RMS over here, I'm actually seeing 340 volts peak peak. So we're looking at this 170 volt. Now, we're not looking at the 120. We're looking at this 170 volt peak is what the meter's trying to block, right? Not the 120 effective voltage. So usually these are rated at lower for AC than it is for DC, because these spikes are going to be riding on top of your maximum rating. So what they're saying, this guy could handle a 750 volt spike above the maximum rating of the meter. So if my meter would measure 1,000 volts AC, then this guy here would handle a 750 volt spike above 1,000 volts. So what the category is, it's not the maximum range of the meter, it's how much of a voltage spike that could handle. Y'all understand? And we'll look at these ratings in a minute. This is where they're set at, though. So category 1 would be for electronic equipment, because this is well isolated from the power source. And then a Cat 2 meter, which is what we would use here. This is single phase. I'm sorry, Cat 3. But Cat 2 meter would be single phase loads, right? You'll understand that. And appliances, TVs, household loads, outlets located 30 feet from a Cat 3 source. Does that make sense? A Cat 3 meter, this is our distribution. So this would be like if I was going to go over there at my panel box and make measurements at my panel box, which is directly from Alabama Power where we go. Distribution level, fixed installations like distribution panels, devices, short branch and feeder circuits, triple phase loads, and single phase loads. So here we have 3-phase loads, we have single phase loads. We don't run into them in this class, but if you get into motor controls, we have 3-phase loads and single phase loads. So that means for our application, you should have at least a Cat 3 meter. And then a Cat 4 meter is over on the distribution side. So this would be on the distribution side, whatever's feeding the building, right? You understand? That's where we need a Cat 4 meter. Now, a lot of these meters are double specified, and which one would be the best? So this is where it gets kind of misleading, because people will come over here and they get in these Cat meters and they'll say, well, this guy right here, this Cat 1 meter is rated at 4,000 volts, right? You understand? What's a Cat 4 meter? But the Cat 4 meter is rated at 4,000 volts. But it's not rated that's not at the distribution 4,000 volts, right? Where you got all this energy. Y'all understand? So the closer you get to the distribution, the more energy is available out of these spikes. Does that make sense? So with this guy here is a Cat 3 750 volt rating. So a Cat 3, this category here could handle a spike of what to what. So if this guy, if ours is 750, which would be right in here somewhere, right? You understand? Okay. And it says it could handle a spike of what? Around 6,000 volts, right? Does that make sense? But on the 600 volt scale. If you went above that, then it would be, we would have to drop down below. We would have to use the Cat 2 rating, right? Y'all understand what I'm saying? Yes or no? Yeah, so when I look at this meter right here, so it says it's rated Cat 2 on the 750 volts. So as long as I'm measuring something below 750 volts, then I get that Cat 2 protection, right? You understand? This is on DC, it's rated Cat 2 up to 1,000 volts. So as long as I'm measuring voltage down to 1,000 volts, I get this Cat 2 rating. If I go above that, then I would have to move down one rating, right? You understand that? This is Cat 3. So this is a Cat 3 rating up to 600 volts AC. So as long as I'm making measurements below 600 volts, I should never make a measurement inside a Cat 3 source above 600 volts with this meter right here. Does that make sense? And this is what we've got. And they're going to, and where do they put this information at? They put this information right down here by the watt, where you plug your meter lead. Now, all these should be either IEC rated, which is the International Council of Electronics or Electricians, or they should be UL rated. So don't go out and buy a little cheap meter that's got Cat 3 in it. You know what these organizations are? They're basically non-profit organizations. What these companies do is they pay UL to test their equipment out. And what UL does is UL certifies that it does what the manufacturer says it will do. So if you've got something that's got a UL stamp on there, then you know that that guy meets or exceeds the specifications that the manufacturer supplies, which is also what IEC does. It's just that UL is basically here in the United States. IEC is an international standard. And I don't know what this is. Yeah, and that's another thing that people don't understand is what we have available to us now is we have the meter leads that are rated at what your meter is supposed to have. So if we look at these meter leads, it looks like this meter's been never been used. So this is a 1,000 volt Cat 3. It's a 600 volt Cat 4 meter lead, and that's if you leave these caps on there. As soon as you take that cap off, then you drop your leader leads down one rating. So now it's a Cat 2 meter leads. Because you've left this much here for arcs, right? You understand? So just about all your meters now are going to come with this little cap, which basically insulates it all the way down to the little tip right here. But as soon as you do what? Take that off and drop down. Or somebody's got or maybe they hadn't. Oh, yeah, they did. So if I come up here and do this, I've dropped down my rating on my meter. So these guys, these are the alligator clips, and just about every meter, and that would be the category rating right there. So as soon as if I come up here and do what? If I fold that back or take it off, you take it off, then you dropped it down a lot. But if I was to come up here and fold this back, then what did I just do? I dropped the category down. Right? Because the more exposed tip you have, the more likelihood you're going to have when these transits come in that you're going to have an arc between your leads or to another section of your circuit. So this is what we're doing now. So in our class, in our program, when you buy your meter, and you're going to have to buy the meter sooner or later. That's part of the in the meter. We required you to have very few tools, but what we want you to do is have the basic tools that you need for your trade, right? And of course, one of your basic tools, one of the tools that you'll use most often is this guy right here, is a meter. You don't want to buy a meter to get you killed, right? You understand? You want to buy a meter that takes care of you if you use it right. It's not going to say you can't get killed not using a meter, but that'd be like saying you won't get killed driving a car, you know. Of course, driving a car is a lot more deadlier than working with electricity, right? You understand that? Voltmeters, ohm meters. So what we got is about what we call a multimeter. So to be a multimeter, to be considered a multimeter, you have to have 3 meters inside, and it's called a multimeter, which means you select one of these meters. So this guy actually literally he uses the same display for 3 different meters. The meters themselves are different, right? You understand? So I put that on a test somewhere. I say to measure voltage, what type of meter do you use? And one of the answers is a digital multimeter. One of the answers is a voltmeter. You'd be surprised how many put a digital multimeter. What's wrong with a digital multimeter for measuring voltage? Yeah, if you don't have it set right, you can get yourself in trouble, right? So what we do with our digital meters, our meters, is we select the meter. So this is, we use this guy here to measure what? The little squiggly line means AC. The little dash line with a solid line, this would be DC. This would measure millivolts AC or DC, which means it's selectable. So you would have to use this switch on this meter to select if you're in millivolts, if you're going to measure AC or DC. This is ohms. We also use this for what we call continuity. What is continuity? In electricity, what is continuity? Huh? Basically, that's what it is. It's a path that has little or no resistance between 2 points. That's continuity. Well, we do that so often that they just about every one of your meters now add a beep capabilities to it. So if you measure continuity, it'll beep at you. You don't have to do what? You don't have to look at it. We use this a lot, checking fuses. How much resistance does a good fuse have? Hardly none. But we use these to check fuses. We check circuit breakers. We trace wires. I can't tell you how many circuits I've had to figure out and by tracing wires. So I put my meter lead on one and I just start touching stuff until it did what? Until it beeped, and then I would draw the circuit. This is microamps DC. This is 40 microamps maximum. This is normal microamps. But notice it's got the squiggly line and the straight line. So that means I would have to do what with this? I would select. This is amps. This is true amps. It says AC, DC, so I'd have to select. But what we find out now is that most of your meters add several other meters besides just those three. This guy adds a frequency counter. So I could actually put this, if I plug this in and put it in Alabama Power, it should come up and say 60, right? And then it also adds a capacitor checker. Some other popular stuff now is temperature meters or thermocouple inputs. Logic, some of them measure logic, so instead of measuring voltage, it'll give you a high and a low, so you can use them as logic probes in digital. So that's to be the optional that some of your meters measure. But to be considered a digital multimeter, it has to contain 4 meters, right? I'm sorry, 3 meters. And what is a 3 meter? A meter, right? Most people say amp meter, but technically it's an ammeter. If you look the way it's spelled, see the way it's spelled. But amp meter's okay. Nobody will correct you. Voltage measures, place the meters, and this is where the big problem we have is people not knowing how to use the meter. We have 2 meters that we put across, and then we have 1 meter that we make things flow through. The 2 meters that we put across are voltmeters and ohm meters. And since we don't have to break the circuit on these are the most popular meters out there that we use. So these are the ones we use most often, is the voltmeter and ohm meter. The voltmeter, what we do is we have power on the circuit. Well, it depends. Out at US Steel, if we were going to connect a meter into a circuit over 500 volts, we would have to turn it off, put the meter in there, and then turn it on. So we literally was not supposed to measure over 500 volts with a live circuit. Okay, so it all depends on where you work at. I imagine it's more stricter than that now. So we didn't have to wear all this stuff. We didn't. There was no such thing as 70E when I was working at US Steel. But what we do is we place the the meter leads across the device to be measured, and we use this to check for voltage or to verify a circuit is de-energized. One of the things that you learn in safety is that we teach a section in the troubleshooting class on lockout tagout. You'll see people go out and they'll take the disconnect, they'll lock it out, they'll come over here and they'll put their tag on it and they go out there and go to work without checking it to see if it is actually deactivated. I mean, it's up to me. I'm pulling a disconnect. What happens if I pull the wrong one? I mean, I got 6 of them up there, and they're not labeled correctly, and I pull a disconnect, and I go out there and start tearing up stuff, and didn't do what first? Check it. So that's what we're supposed to do. When I do that, before I start working on it, the first thing I'm supposed to do is check with a voltmeter to make sure there's no voltage available. If there's no voltage available, there's not going to be any current, right? You understand that? Another thing that a lot of people don't understand is you're supposed to disconnect all sources of power. And what's our 3 sources of power? Electrical, pneumatic, hydraulic. So if we've got pneumatic or hydraulic systems, we need to make sure those are disconnected. And it all depends also, and we're supposed to get rid of all stored voltages, all stored pressures. So that means if you got an electrical system that's got a battery backup or something like that, that's a storage system, right? Pneumatics does definitely have a storage system. So what that means is you're supposed to go like to your compressor or something and bleed that thing off, right? Kick that safety relief valve on there. Hydraulics, it depends on whether it's got what we call an accumulator on it or not. Some hydraulics have a big tank that has a huge weight or a big spring on it that when the hydraulic system is working, it fills that accumulator up. And then when you kill power, it develops pressure off that accumulator. Now what this does is it smooths out the whole system for varying loads. So you're out there moving actuators and it has a big demand. And instead of me choosing a pump that meets my biggest demand, I can choose a pump that meets my average demand. And then if I exceed that average demand, it will feed off the accumulator, right? You understand? So it smooths out the hydraulic system. Also, it'll give us a pressure source if power fails. So if your power fails and you got to put something in a safe condition, you will still have a little hydraulic power, so you can do what? You can use these manual overrides to move that. So what are you supposed to do on that? Well, you're supposed to bleed off that accumulator, right? You understand? Or disconnect it. Some of them have a disconnect. Ohm meter resistance. We put only made with power removed from the circuit under test, measured across the device to determine the resistance. Everybody okay? So what's the difference between a voltmeter and an ohm meter? One of them's with power on, the other one's what? Power off. Everybody okay? Don't ever put your ohm meter into a circuit with power off. Could damage the meter. Could damage you too. Ammeters measure current. A true ammeter. Now, this is where people get confused. And I think I got one in here, but I don't have one. Yeah. So this is what we call a clamp-on ammeter. Now, how does this thing work? Does it measure amps? Sort of. What it does is that when we put current through a conductor, it creates a magnetic field. What the clamp-on in the magnetic field that is generated around that conductor is directly proportional to the current flow through it. So what an ammeter does is it measures the strength of the magnetic field. You see why it's called a clamp-on ammeter, right? So what do? We take our one conductor. We don't put 2 conductors unless we want to measure the differential current. Put one conductor through here, open it up, put the conductor in there, and then we come over here and select. Usually this is an auto ranging meter. And what it's doing is not an ammeter, it's a clamp-on ammeter. So what it's doing is it's measuring the what? The strength of the magnetic field. Most of these guys will only measure AC because we have to have motion, and AC automatically generates what we call motion to make these things work. Some of your more expensive one has what we call a it uses an electronic circuit called a Hall effect sensor. Hall effect sensors can measure the strength of a DC field. So I don't know if this one does or not. This is a true RMS meter, so this is a high dollar meter, right? We already talked about that. And this is not only a high dollar, this is also a what? Fluke. So a fluke is not a fluke. A fluke is probably one of the best meters put out there, with the best name meter that they have out there. So this is a clamp-on fluke meter. Yeah, meter leads go here. And this one don't have it. A lot of your clamp-on meters will have snaps on one side. So what you can do is you can you hold your meter in one hand and use this to establish one polarity, and then use your other ones. So this one doesn't have that feature. So yeah, this is where the meter holes go. This is a Cat 3 600 volt meter and a Cat 4. So this is a Cat 4 meter, but it's only guaranteed up to 3. If you're measuring voltage above 300 volts. Yeah, but you have to be kind of careful, because a lot of times the DC is with these guys down here, and it would be a true amp meter. So most of your clamp-on amp meters will measure DC current, but it is an amp meter that you measure it with. It is not a clamp-on amp meter, right? You understand? And that would be in the specifications. I would have to look this up. I said ICE, guys, but it's actually CE. So this guy here is CE certified. So what we're doing is, when we look for the category, we want to flip the meter on back and see if it's either CE certified or if it's UL certified. Both of those are good. If it don't have that, then don't trust the Cat. It means this company has said I have a Cat 4 meter, but then they have had nobody to go out and do what? Yeah, I'll verify that for you. It depends, not usually on AC. Usually the only thing that's fused, the only one that's fused is your current scale. Your voltage scales are not fused. So you don't blow the fuse on your not unless you blow something up in the meter. The amps, yeah, it's fused. Your clamp-on is not fused. It don't have to be, because if you exceed the range, it'll come up here and just give you an overload. Because all it's doing is just sensing the strength of the field. But yeah, if it's an amp meters are going to be fused, and that's something they've changed also. I've got a fluke meter, but I've had it for years, and the fuse for the amp is snapped on the battery. What we do now is the fuses are inside the meter, and they're actually isolated from each other. So the fuses are actually insulated from each other on these new meters. Your old meters, insulated from battery. Now they're not. Everything is insulated from each other. So my fluke, which is a top of the line meter, if you snapped off the battery, it's got a snap for the battery. None of our meters now has a snap off battery compartment. To get to the batteries now, you have to unscrew the back. So the meter is sealed up. My fluke's got a little snap door. I snap it off, kind of like you do on a remote on the TV. And it's got a 9-volt battery on it, and the fuse is on the side of the battery. So that's how much meters have changed when they started. Yeah, that's a manual range meter. Yeah, so it's got my fluke's got all the buttons on the side over here, and which I prefer. I prefer a manual ranging meter over auto ranging meter, but they're getting harder to find. I like a manual ranging meter because I don't have to figure out what scale is in. So on this, you're looking for milliamps, microamps, and that kind of stuff, and trying to figure out. And we have this happen all the time in DC. They'll write down 100 ohms, and it's actually 100 k ohms because they don't pay attention to the watt. And then plus these, this is a 4,000 count meter. So this guy, and another thing that we have with these, with all meters and even test equipment does not use illegal engineer notation, because it's trying to limit the number of ranges. And these meters, they don't scale on powers of tens. They scale. We have 2,000 count meters, we have 4,000 count meters, and we have 6,000 count meters. Now that don't mean much to you, but a 4,000 count meter would change ranges on 3999, and then it would range. So what that means is I've got it on ohms up to 399. It would change ohm. It would show ohms. Then what it would do is it would range on me, and it would say 0.400 K, which is actually it's still 400 ohms. So meters or test equipment they don't use legal engineer notation because they don't have as many ranges available. Does that make sense? So they don't. So and then the counts, the analog to digital converter they use runs off counts. And of course, the higher the number of counts, the more precise the meter can be. So a 6,000 count meter would cost more than a 4,000 count meter, which would cost more than a 2,000 count meter. And this would be in the specifications. So if your meter ranges on twos, like it goes to 199, and then it ranges to the next range, and you got a 2,000 count meter. If it ranges at a 4, I'm talking about the most significant digit. So if it goes to 3999, usually it's 4 digits. If it goes to 3999 and then it jumps to the next range and goes to 4, then you got a 400 count meter. If it ranges on 6s, then you got a 6,000 count meter. So I think this is a 4,000 count meter. I'm not sure. Next time, if y'all do the meter certification, see where it ranges at. I'm not really sure. And this one right here, I don't know. Most of our meters now are 4 digits. We call them 4.5 digits, even though it's not a half, because the most significant digit will range on 2s, or range on 4s, or range on 6s. So your most significant digit, you'll never see a 9 on. Does that make sense? But don't. That's just the way it is. But the ammeter, a true ammeter, you got to let the current flow through the meter. So what does that mean? That means you got to break the circuit, turn the power off, break the circuit, put the meter in the circuit, make sure it's set up for amps, turn the power on. Now the problem we have in DC, guess what the problem we have in DC? Blow fuses. What do you think they do? They put it on amps. No, they put it on amps. They measure amps. Then they don't take the power off. Then they hook their circuit back up and they want to measure volts. They take the meter and stick it in there without checking to see. They don't switch it back over to volts. So that's one thing you got to learn how to do on these meters is check things, double check things to make sure you got it right? So this is a meter set up to measure volts. Now this shows us a relative to ground or common, circuit common. This is probably the best way to make your measurements. And so normally what we like to do is get an alligator clip. We clip our black lead or our common lead to the circuit, and then we probe with one lead in the circuit. Now why do we want to probe with one lead? Why is it safer? Because you only use one hand. And then your meters there's no way in the world you can get the leads close together, right? Well, what you're going to have to do is you're going to have to know the voltages inside, instead of knowing the voltage drop across that resistor. If you go across 2 resistors, then you're going to have to know the voltage drop across those 2. So usually electronic schematics, if it gives you voltage measurements, they are relative to circuit common. So I might have a resistor there, and it might show 6 volts on this side, and it might show 15 volts on that side, right? You understand? Now, if I measured across it, it would measure 9 volts, right? You understand? So just about all your schematics if they give voltages, they're going to be relative to circuit common. So that means this is what you would do. You take the black lead and hook it up to your circuit common, and then do what? Probe with one lead. But you can probe inside the circuit if you want to, right? You understand? So you don't have, with a voltmeter, You don't have to probe relative to circuit common. And if you're doing AC, guys, if you're doing AC, the black lead and the red lead mean nothing. Y'all understand? Means nothing. So you can take the red lead and put it on your common, or you can take the black lead and put it on your common. It makes no difference. On DC, the only thing it does is if you use the black lead on your common, it gives you the correct polarities. If you use the red lead on your common, everything that was supposed to be positive is going to measure what, negative. So this is your meter common. This is not a circuit common. This is your meter common. So your meter makes measurements relative to this, but in AC, what happens to the polarities? Yeah, they keep switching. So your meter has no polarity. Current measurements with a multimeter. Remove power from the circuit when attaching or disconnecting leads. If possible, use alligator clips to attach the meter leads to the circuit. Place the black lead, and this is not, I don't know what this is. Place the black meter lead in the meter's common. This is true. Place the black meter lead in the meter's common terminal and the red lead in the lower high amp meter terminal. Y'all understand that, what that is now? So this meter has 3 amp scale. It's got one that's got a maximum of 40 microamps, and it's got a microamp scale, and then it's got an amp scale. And now normally what they'll do is they'll have the meter fused for different. If you got different amp scale, what they normally do is have different. They have different connections for your amps. So it says if I'm using amps, I'm supposed to use this guy. If I'm using milliamps or microamps, I'm supposed to use this guy. Now, what do you think they're changing? You're changing the fuse that the signal goes through. So this one would go through whatever this is rated. So this guy's fused at 10 amps. This guy's fused at 500 milliamps. So that's basically all you're doing. You're switching between fuses, right? You understand? Now, of course, what they'll do is if you're over on this one, then your microamp scale probably won't be valid. I had a Craftsman meter that when you put it on amps, or I'm sorry, when you put it on volts, it would cover up the amp leads in here. So if you had it on volts, you couldn't put it on amps. It wouldn't let you because the lead was in here and that little door would try to move and it wouldn't let you turn the knob. And so if you had it on volts, it would cover up the amp. If you had, I like that because it kept you from making mistakes. Also, what they've done, your old meter leads didn't have this. Your new meter leads will have this covering over here. So if you look at the actual leads themselves, notice they separate that. See that? Yeah, so your new meter leads, the banana, we call these banana plugs, they're actually encapsulated in something. And why do they do that? I don't care how many times I've dropped the meter and I've got my scope leads, my meter leads up here, and when I drop it, what happens? Them suckers do what? They pop right out. If you got those regular banana plugs on there, then that sucker, and if both of them pops out and they start swinging, that's pretty interesting. So we don't have that feature anymore. So for my Fluke, when I buy meter leads now, guess what I have to do? I have to cut that off. My Fluke, you can't use these in my Fluke. So it's an old meter. But it's been good to me. I ought to bring it in, let y'all see it. Man. I got Simpson 260. That's when we was out at US Steel, that was the meter they gave us. So we had analog meter. Good old Simpson 260, that's a good meter too. It's a pointer meter. Select AC or DC amps, and the manual range meter is used. Select the appropriate current range. With power removed from the circuit, break or open the circuit, place the meter leads across the open, in line, or in series. With measuring DC, place the red lead toward the positive polarity and the black lead toward the negative polarity. Now, really, it don't make any difference. It's just that if you put it in there backwards, it'll measure negative, right? Apply power to the circuit, record the reading, remove power, remove the leads, and reconnect the circuit. So what I've done here, I said you only need to only honor this if you're measuring what? DC. If you're measuring AC, it makes no, your meter leads make no difference. So this is an example of a meter set up to measure current. By the way, you can literally break the circuit anywhere that's in a series path if you want to measure total current in the circuit. So we could have broke it here. We could have broke it here. We could have broke it here. We could have broke it here, right? Which would be the same as breaking it right there. Measure resistance. The first thing it says is what? Yeah, remove power, place the black lead in the meter's common terminal and the red lead in the V ohms terminal. Normally the volts and ohms are share the same terminal. I haven't seen a meter in a long time that don't share those terminals. But record the reading. If a bad reading is recorded, isolate the device being measured by disconnecting one side. Y'all understand that? Yes or no? Why? Why? So you're not reading the rest of the circuit. You understand in electronics we got series parallel circuits. And my meter lead is looking for the other lead. And if it can find a path back to that other lead, that's a shorter path other than the one I'm using, it's going to give us the wrong reading. So it's the rule of thumb is that if it measures good in circuit, we assume it's good, right? If it measures bad in circuit, then we isolate one and read. Because I might measure a short, but the short might be somewhere else in my circuit, right? Remove the meter. So this is measuring resistance. So we got to make sure we do what? Turn the power off, right? This is an auto ranging meter. Trying to see if I got a Crestron meter. No, mine's not angled like that. One of my meters is a Crestron meter. It's an auto, so I got a Crestron auto ranging meter. Then my Fluke is a manual ranging meter. So what would be this guy? This would be at least a 4,000 count meter, right? Okay. This is an analog meter. Analog meters are still available. You can buy them. We don't use them that much anymore. The problem is your analog meter doesn't use a linear scale on your ohms. These scales down in here, these are linear, but what you got is you got a different scale that you use depending on what you're measuring. So if I was measuring DC, I would use this scale, and then the scale changes according to what range you have selected. See that? So this is, if I was using the 250 volt range, then I would use this scale. If I was using the 50 volt range, I would use this scale. If I was using the 10 volt range, I would use this scale. If I was measuring 100 volts, which this meter don't have, then I would use the 10 volt scale and multiply everything by 10. So usually if it's got a 100 scale, it don't repeat those. The ohm scale is nonlinear. And that varies depending on what range I have, right? Here's the AC scale right here, the red one. The black scale, which is a linear scale, that's this one. This is the AC scale that's red. This is milliamps. This guy does microfarads, so this guy actually measures capacitance. This is what we call a mirrored scale. And what's the problem with this? Why is this best right here? That would mirrored scale. Why do you need one with a mirrored scale? See this mirror behind there? We call it a mirrored scale, but usually it's just a polished piece of metal. Yeah, well, the problem we have when we have something that's separated like this, so this does not touch that. If I look this at an angle, if I look at it at an angle, we refer to it as parallax error. So what it would do is it would actually mean that you think you're measuring less than what you're measuring. So what makes you look straight ahead? So if you look on that and you see multiple dials, what you do is you let you know you're looking straight ahead. Yeah, cars used to be scary. You ever rode with a car that had a speedometer on it, and you're sitting in the passenger side, and you look over there and you have no idea what speed you're going because of what? Because of this parallax error, you're looking at it at this angle. So, thank goodness. They went to digital speedometers for a while, but they took those out. I don't know if y'all remember the digital speedometer. Now sometimes they have a combination of both. You know why? Because people want to look at them all the time. If you drive a car long enough and you understand your speedometer, you can tell how fast you're going without actually looking at it now, right? So, clamp on ammeters. Voltage and resistance measurements are made the same as with a multimeter. Current, most clamp on meters will only measure high current AC. Meters that measure AC and DC current are available at a higher price. If a manual ranging meter is used, select the right range. If using a meter with an AC-DC current, select the correct unit. With power on the circuit, open the meter clamps and carefully place them around a single conductor. What if you place it around two? It's going to give you the difference, right? We do this sometimes in motors to see if we got an imbalance between our phases, which is pretty neat. So they'll put it around two, because in a motor, if you got it set up right, all the three phases should be matched on perfect, pretty close to it. Close the clamp to make the reading. Open the clamp and carefully move the meter. This is a digital clamp on ammeter. This is an analog clamp on ammeter. So this is the clamp on ammeter right here. Oh, by the way, a lot of your, this is a clamp on meter, but a lot of your meters have a clamp available that you can buy, where you can just punch it in there. But what you do is you don't put it on amps, you put it on volts. Are we okay? No, but it gives you a scale. It would say, okay, if you have, like, if it's on a 10-volt scale, then every volt would equal 1 amp or something like that. So if they come up and measured 1 volt, you would know it would actually be what? 1 amp. That answer your question, Joe? Makes sense? Yeah, we used to have one of those around here. And then it says assignment 3, but there's a quiz on there for basic electricity. So when's it due? We just finished up the basic electricity lecture. When's it due? A week from today. Y'all understand? There's actually 2 sections. There's a part 1 and part 2. Yeah. Where's those at? They wasn't there, but they're there now. Yeah, what we do is we'll go in and turn those off after every semester, so those students can't go back in and redo those quizzes and say I gave them the wrong grade. The topic quizzes, by the way, you can take those twice, because if you take them more than twice, you're memorizing instead of learning, right? So what we have it set up for is you go in, and if you take it once, if you don't like your score, you record what you're having problems with, you do some read up on that and study a little more, and then you can go back and retake it. Everybody okay? So inside the section for the class, inside where would these be at? Where would the topic quizzes be at? Probably in course content. And then wonder where they'd be at here. Topic quizzes. And then they're split into copper and fiber. So we're dealing with copper right now, right? Because we're dealing with electricity. And then basic electricity 1 and 2. Are we okay? You can see we're going to deal with soldering in this class. Any of y'all ever soldered? Did you learn how to do it yourself, or did somebody teach you? So we'll